It's Clive Rocksinger here. This is two-stage amplifier design revisited for about, well, what we're looking at here, 1, 2, 3, 4 times I've rewritten the same file in different formats. Graphics been completely redrawn, mathematics, I've got to try and retain the same math. What this was a theoretical circuit that I actually built and then tested. I got it all working and checked the real values against the theoretical, and so this is an extremely good base model. It's bipolar, BC 108s, it's capacitance coupled, so this is a really bad amplifier. It tends to transfer errors from one transistor to another. Very hard to get to work properly, but it works okay. Now this talk is about these things. I'll come back to this is real life. I'll come back to that circuit. Now, what was that circuit? It was set up. I've even put all of the resistance values on there. Where are the inputs? I have no idea. You pull one wire out, you've got to work the whole circuit through again. If you were testing it, how are you going to get the same values? Oh, that's right, I changed the resistance, all the values are different. You got to know what they are. This one I don't even know what that circuit is. This one I have a little bit of an idea. This one I have no idea. This is my AES method of doing circuit analysis. These boards, which I've got another one here, are very cheap. They're not as expensive as those stupid breadboards. You change that over, you can also cascade those and in different levels. This of course is a prototype. I've come back to this. I've got the name of the thing on the back there which you can't see. And you plug it in and voila, you have lights, camera, action. Hang on, turn it to, it's working because it's all bolted on. And if you do a component, you can actually put another one in there and then actually screw in like a trimmer and get it nearly exact, and go back to the original thing, and you can test it and test it and test it and retest it, and you're going to get some results. And this, I'll have to revisit this 50 times. I've had this set up probably since last year. And this is a perfect example of why you don't use these stupid breadboards. You can't mark them, you don't know what they are, you don't know where the inputs are. How the hell are you going to test that? And then of course once you bend those wires 3 or 4 times, they break off and that's the end of it. And what are you going to do, build it all again? You can't. What do I run through this? Sine wave, put it up to... See, the response to that's awful. That's its response. That's frequency response. Well, that's not bad when you slow it down, but it's not a very good amplifier. It's only a BC 108. That's a single stage. And that's actually what I'm setting up here. Turn that off. What I'm setting up here, this is a 2-stage capacitance coupled amplifier. This is the internals. This is your hybrid pi model. And what I found is that the R pi and RO are actually internal resistances. So what you do is you find out what these values are, which I've got your voltage at your mirror and your voltage at your collector, your voltage at your base and all that sort of thing. And then you calculate R pi and RO, which are internal. And they're based on thermal voltage. So whatever the temperature is, changes the output. So what you have to do is I have to set up a thermal room for this. I'll do it with plexiglass, and I'll house that whole unit in a glass case, in a plexiglass, you know, that's sort of the clear plastic little room, which is only going to be about that wide. And I've got a heater there that's actually thermally, you can actually thermally control the temperature. There's a weather station I want to buy, which will probably go up in price, but yesterday it was $250 and it was 300 and something at the electronic shops. I'm hoping Ken will hold on to that for me. I've got to actually go in today. I might even pick it up today. It'll kill me financially, but I've got to get it. You've got to test it at different temperatures. Not really regular temperatures, room temperatures that you're going to get a big change. You've got to get it up to the equivalent of 150 degrees to get a real change in it, or drop it down really, really cold. I can't get it cold, but I can get it really, really hot. And that will change your thermal voltage. And I've got the mathematics for your thermal voltage. And this is the mathematics. I'm an applied mathematician. I wrote those formulas. I did a power calculation with a hybrid pi model, drew the circuit for it and calculated power input to the base of a transistor and got an output. That's not accounting for internal capacitances, but that's another type of circuit. But I think that actually affects signal and not this. I think this may be to do with your biasing or something, and I think your signal might be where you got all your capacitance and that. I think that's where that all comes in. Not really sure. I think it might be signal. This is all your power circuit. This is your driving circuit. I think the other type of model, and I think S-domain analysis may be your that'd be Fourier, so that's your signal, and that's where the capacitance affects things. Capacitance, this part of the circuit, doesn't do anything, I don't think, in a power circuit. Power frequency and signal frequency are different. They're not the same. I put an AC power supply, got it running straight out of the mains, and I put capacitors and coils and all sorts of stuff on the circuit, and I couldn't get any change in the waveform at all. I put the crow up. So, this is two-stage amplifier design. Shaz is a bad girl. She's covered in tats and she's got a mouth, but she's a lovely girl. Yeah, there's a bit of a message there. You know, don't misjudge these girls. And there's so many shills on. I mean, not that I watch porn. Good Lord, no, I don't do stuff like that. No. I watch the news. But there's just so many girls doing, you know, work that they shouldn't be doing. There's too many of them, and they have terrible lives. A lot of these girls, you know, young girls, and you know, daddies having fun with them. My God. So Shazza sort of represents that girl. She's been knocked around. Anyway, so this I can now put it through a second stage of testing, and I'm going to apply thermal voltage. I'm going to get this circuit hot, and that's the mathematics of it. As you can see, there's a fair bit of math. I'm going to get this thing cooking hot and see how it behaves. Clive Rocksinger, over and out.